Hi everybody, welcome to the fourth part of chapter 9 of class 9 CBSE. This is from the NCERT book. In this part, we are going to be looking at the numericals that are given at the back of your chapter, at the end of your chapter. And I hope you have seen the first three parts before you have come to this one because you will not understand anything that is going on unless you have seen the first three parts, right? And in this chapter, in this part we are going to look at the numericals. So you should have your book or book open, and along with that have a notebook so you know how to solve them. And you will find explanations online also, but you will not be taught how to do them step by step. वो ऐसे ही लिखा होता है. Oh, so if you are interested in seeing why things are done that way or to find shortcuts, it is good to see a video, right? Okay, so let's start. The first question is, a truck starts from rest and rolls down a hill with constant acceleration. It travels a distance of 400 meter in 20 seconds. So firstly, we'll write whatever is given here. At rest means initial velocity is 0 meter per second. Distance is 400 meter. Time is 20 seconds. Right, we have to find the acceleration. Right, the final velocity is not given, but you have many different formula to find the if you have seen the chapter on motion, then you should remember these formulae. We can use the position and time relation in this. Okay, so S is equal to ut plus half at square. Since u is 0, this whole term becomes 0. So S is equal to half at square. This can be simply written, right? 400 is equal to half into A into time. T is 20. And what is the square of 20? 400, right? So this term becomes 1, right? It gets cancelled, 400 upon 400. So A is equal to, we take this and multiply, it becomes 2 meter per second square. Right, this is the acceleration. Find the force acting on it if its mass is 7 tons. Right, what is force? Mass into acceleration, which means mass is 7 tons. So 7 into 1000 kg is 7000 into acceleration is 2, so 14,000 Newton. All right, or kilogram meter per second square. Right, this second is, a stone of 1 kg mass is equal to 1 kg is thrown with a velocity of 20 meter per second. U is equal to 20 meter per second across a frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What does this mean? Comes to rest means final velocity is 0 meter per second. Distance is 50 meter. What is the force of friction between the stone and the ice? How will we, what does the force of friction do? The force of friction is bringing this to rest, right? When it comes to rest, it is because of force of friction. So what is the force of friction? What will do we have to find? Firstly, we have to find acceleration. We have been given mass, F is equal to ma, right? So we have been given mass, we have to find the acceleration. In this case, the acceleration will be negative, right? So because the object is coming to rest. So we have uv and we have the right. So but we don't have time. So what we can do is, for a we can use this, we have been given s, so we can use this formula. 2as is equal to v square minus u square. V square is 0, so 2 into acceleration into 50 meter. V square is 0 minus u square is 400. So 100a is equal to minus 400. So a is equal to minus 4 meter per second square. Okay, so this is acceleration. Now you find, simple, you find force. Force is equal to, mass is 1 kg into acceleration is minus 4. Please keep in mind that you have to keep in mind these negative and positive signs, because force can be negative also, right? Negative force, because it is force of friction, it is working against the direction of motion. So this is minus 4 Newton. Okay, minus 4 Newton is the answer. Next question. 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg, along a horizontal track. Now in this we have been given the mass, but we have to add all of this because there is an engine. engine का mass है, and then there is the mass of these 5 wagons, each of 2000. So total of 5 wagons is 2000 into 5, that is 10,000, right? And the 8000 kg engine, so it is 18,000 kg, right? So 10,000 of these 5 wagons and 8,000 of this engine. So total mass of the train is 18,000 kg along a horizontal track. If the engine exerts a net force of 40,000 Newton, 40,000 Newton, and the track offers a friction force of 5,000 Newton, let me write it like this. Why have I given this a negative sign? Because friction always opposes the motion. Opposes the direction of motion, so it will oppose the force that is given here, right? So what is the net accelerating force? It will be the force that is exerted by the engine in this direction minus the force of friction, right? Because friction moves in this direction. So what is the net force? Net accelerating force would be 40,000 minus 5,000, that is force net is equal to 35,000 Newton, right? Find the acceleration of the train. Now what is acceleration? Force is equal to ma. We have the mass, we have the force. So A is equal to F by m, that is A is equal to 35,000 upon 18,000, right? So what is the answer of this? This comes to around somewhere around 1.9, right? Because 36,000 would have been 2. So this is 1.94. Okay, 1.94 meter per second square, right? Okay. Okay, next question. An automobile vehicle has a mass of 1500 kg. Mass is equal to 1500 kg. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? In this, they are just talking about the frictional force, right? But it is simple. It is the same formula. You don't have to do anything. Force is equal to negative acceleration. Please keep in mind. So A will be minus 1.7 meter per second square. So M into A is equal to force into is equal to 1500 into minus 1.7 is equal to um, 2550 minus 2550 Newton. Why is it minus? Because negative acceleration, it is coming to a stop. It is frictional force, right? It is opposing the motion. So it is minus 2550 Newton. Alright, simple, very simple. Next question. Using a horizontal force of 200 Newton, so force is already given, 200 Newton. We intend to move a wooden cabinet across a floor at constant velocity. What is the frictional force that will be exerted on the cabinet? Now there is nothing else given. इसका तो simple logic ऐसा है कि frictional force, when does an object move with constant velocity? When there is no additional force, external force acting on it, right? This is the first law of motion. When there is no external force acting on an object, it moves at constant it remains at rest or moves with constant velocity, right? Or maintains its state of motion. So in this case, if there is no net force that is acting, which means that if we are giving it a force of 200 Newton and it has to move with a constant velocity, therefore frictional force is such that it will be exactly opposite to this, so that it is moving, वो चलता ही रहेगा. If you give it more, so frictional force will be equal to equal and opposite, because frictional force always opposes. So frictional force, this answer is minus 200 Newton. Why is it so? If you have more force than the friction, then the cabinet will not move at a constant velocity, then the velocity will change, it will be accelerating motion, right? In this case, since frictional force is equal to the horizontal force that you're given, therefore there is no net force, therefore the cabinet, which was already in motion, we assume it is already in motion, it will move with constant velocity, right? So the frictional force is minus 200 Newton. Next, two objects, each of mass 1.5 kg, are moving in the same straight line but in opposite directions. Right? These are two objects, 1.5 kg, 1.5 kg. In this direction, in this direction. The velocity of each object is 2.5 meter per second. दोनों की है. Huh? Before the collision, during which they stick together, what will be the velocity of the combined object? Now, stick together and combined object means they become one system. So therefore, whatever velocity they attain will be for both these objects, right? And mass will be the sum of these. Now, iska ek simple thing here. You of course you have to solve it. You have to solve it in a paper, but you can know the answer immediately. If this is moving at the mass is 1.5 kg here and 1.5 kg here. This is moving in this direction, left to right is plus, right? Plus 2.5 meter per second. And here it is moving from right to left, so it is minus 2.5 meter per second. So if you look at them, if they collide, then what will be the velocity? The velocity comes to zero. है ना? It comes to zero. So if it comes to zero, then what will be the velocity after this? The velocity after collision becomes zero. You can easily solve this also, right? Velocity, you found the answer. Velocity of the combined object will is 0 meter per second. Both of them come to rest because they cancel each other out, right? Or you can also do it like this. You can say this is object A, this is object B. So M A U A plus M B U B is equal to, since the combined object की velocity है, so we can use only one, we can use V as the velocity of both these objects together. So MA plus MB into V. So MA U, here UB is minus. So MA 1.5 into 2.5 minus 1.5 into 2.5 is equal to, what is the total mass? 3 kg into V. Simple hai, this is the same thing, so it becomes 0 is equal to 3V, V is equal to 0. The objects come to rest, the combined velocity becomes 0, right? Okay, you could see it even otherwise, but you have to solve it in a paper. If you're giving if you are writing a paper, you have to solve it mathematically. So you have to know, you have to be able to show how it is done. You have to use the law of conservation of momentum, and you can show this. But otherwise, this is an oral question, you can easily solve it. Next question. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as to return. Please read the question properly. So as to return along its original path with a velocity of 5 meter per second. Return. So what happens? This is a hockey ball. Hmm? It is moving with the, this has mass 0.2 kg, है ना? 200 gram is 0.2 kg. Traveling at 10 meter per second. Then a hockey stick puts it back along the same line with a velocity of 5 meter per second. So what can you say about this? Since the directions are opposite, same line but opposite directions, then this velocity we can consider with a minus sign, right? Calculate the magnitude of change of momentum. What is change of momentum? Momentum is mv. Change of momentum is m into v minus u, right? So this is change of momentum. This sign is for change, right? In this case. So delta P is m into v minus u. Now you have to consider that This is minus. So delta P is equal to M is 0.2 into V is minus 5 minus 10. So delta P is equal to 0.2 into minus 15. Right? 2 into 15, this is 3 minus 3. So change in momentum is minus 3 kilogram meter per second. Right? Occurred in the motion of, this is the change of momentum that has occurred. It is minus 3 kg meter per second. Okay. Next question. A bullet of mass 10 gram. Mass 10 gram is equal to 0.01 kg. है ना? Traveling horizontally with a velocity of 150 meter per second, strikes a stationary wooden block and comes to rest in 0.03 seconds. Right? Calculate the distance of penetration of the bullet into the block. Now you have to see the distance covered after the decelerating or negative acceleration has been, the force has been put on the bullet. Now you want to find S. Now what do you find first? We know that V is equal to 0, right? Because it comes to rest. So what we can do is, first we can find the acceleration, right? Because S, you always have to find the acceleration in both of those cases, both the formulae. You need acceleration. So you look at acceleration, A is equal to 0 minus 150 upon time. Time is 0.03. Again, it is minus because it is negative acceleration, it is stopping, into 100 upon 3, right? Because it is divided point by 0.03, we can multiply it by 100 and then you can make it, you can remove the decimal place, है ना? Minus 50 is equal to, A is equal to minus 5000 meter per second square. With a high velocity, it is stopping. Okay. Now when there is such high velocity, negative acceleration, the distance covered, we take S is equal to, you can use either of the formula. You can use S is equal to ut plus half at square, but you can also use v square minus u square is equal to 2as. I'm going to use, I prefer the second formula always. So v square 2as is equal to v square minus u square. 2 into acceleration is minus 5000 into S is equal to v square is 0 minus u square is 150 meter per second. Okay. Or you don't have to, don't write down. Oops. ठीक है. So minus 10,000 S is equal to minus 150. This gets cancelled. S is equal to 150 upon 10,000. So 0.015 meter. Okay. This is the distance that is covered, right? So this is one of your answers. Also calculate the magnitude of force. What is magnitude of force? F is equal to ma. Mass is 0.01 into acceleration is 5000 is equal to 50 minus 50 Newton. Right? This is the force that was applied by the wooden block on the bullet. Why is it minus 50? Because it is making, it is an opposing force, right? It is not pushing the bullet, it is stopping it. So this is the answer. So these are the two answers. This is distance is 0.015 meter and force is minus 50 Newton. Next question. An object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Now what all do we know here? Mass of object is 1 kg. Mass initial velocity of object is 10 meter per second. Collides with and sticks to a stationary wooden block. What does this mean? That u of the block is 0. Initial velocity of block is 0. Right? They both move off together in the same straight line. Right? So mass of the block is 5 kg. Calculate the total momentum just before impact and just after impact. Now we know that the momentum just before impact and just after total momentum will be the same due to law of conservation of momentum, right? So we can just calculate the total momentum just before impact. Here we can say MOUO, this is momentum of the object that is moving, plus momentum of the block is, since UB is equal, okay, I'll just write it MBUB. This is the initial momentum, right? P initial. Okay. UB is 0. So this term becomes 0. So what is the initial velocity, initial momentum? P initial is equal to 10, 1 into 10. So 10 kilogram meter per second. Right? This is the initial momentum. This is also the final momentum because of the law of conservation of momentum. So Pi is equal to P final is equal to 10 kilogram meter per second. Also calculate the velocity of the combined object. Now what will be the velocity of combined object? PV combined object will be mass, total mass, that is 6, 1 plus 5, and what is the total velocity we have to find? V. So 10 is equal to 6V, V is equal to 10 by 6, that is 1.66 meter per second. Okay. This is the answer of for final velocity of the combined object, right? These are the two answers that you have, 1 and 2. All right. So we come to the next question. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second. So u is equal to 5 meter per second to 8 meter per second. So v is equal to 8 meter per second in time is equal to 6 seconds. Calculate the initial and final momentum of the object. So initial momentum of the object is mu. This is the initial, and mv is the final momentum. Okay. So initial momentum is mass into this is equal to 500 kilogram meter per second. Final momentum is 800 kilogram meter per second. Simple, no? Sorry, not this. Kilogram meter per second. How is it 800? Because mass is 100 and final velocity is 8. So 8 into 100. Okay. Also find the magnitude of force exerted. Now what is the magnitude? Change of momentum. Now we know the two momenta. And here, what is the change in momentum then? 800 minus 500. This is the 300 kilogram meter per second is the change of momentum. And what is the rate? You have to divide it by the time. So divided by 6 is equal to 50 meter per kilogram meter per second square, or you can just write Newton. So 15 Newton is the magnitude of the force applied. Right, and it is positive because the velocity is increasing. It is in the direction of motion. Okay, so the next question, how much momentum will a dumbbell of mass 10 kg mass is equal to 10 kg transfer to the floor if it falls from a height of 80 centimeters? So what is the distance? 80 divided by 100 is 0.8 meter. Take its downward acceleration to be 10 meter per second. Why? If it is downward, why is it not negative? Because it is dumbbell is also falling and the acceleration is also in the downward direction. So it is 10 meter per second square. Initial velocity is 0 and v you have to find first. Okay. So we can use the formula 2as is equal to v square minus u square, right? 2 into 10 into 0.8 is equal to v square minus u square. 8 into 16 is equal to v square. U square is 0. So this becomes 0. V square v is equal to under root of 16 is 4. Right? So this is the final velocity with which it falls to the ground. Right? And we have to find the momentum. P is equal to mv. Right, because initial उसका जो momentum था वो zero था, because the initial velocity was zero. So you have to find the velocity with the you have to find the momentum with the velocity with which it reaches the ground. ठीक है? So P is equal to mv. P is equal to mass is 10 into velocity is 4. So P is equal to 40 kilogram meter per second. Right? ठीक है. Next, the following is the distance time travel of an object in motion. What conclusion can you draw about the acceleration? Is it constant, increasing, decreasing, or zero? How do we know if an object is accelerating? If the velocity increases with time. Here we have been given distance. How do we find the velocity? I will give you a shortcut after I tell you the long thing. Okay. Now the distance is this. What is distance? Change in distance upon time. This is speed, right? This is the velocity. So we look at the change in distance. This is 1. The time always remains 1 second. This is 7. This is 19. This is 37. Anyway, so we can just take this. We can take a few. You don't have to do all of them, right? But if you take these, we can look at the change in the distance. So change in distances, here it is 1. In 1 second, it is going from 1 meter per second, right? 1 meter in 1 second. Here it is going 7 meters in 1 second. Here it is going 19 meters in 1 second. So what do we say? The velocity keeps on increasing. But is it increasing at the same pace? That is what we want to see, because we can see that it is accelerating. But is it accelerating in the same uh, with the same amount every time? No, right? Here this is velocity, right? So this is the distance. Is this distance increasing with the same difference? No. The difference is also increasing. Here the difference is of 6. Here a difference is of 12. So we can see that this distance is also increasing. Do you see? Do you get my point? So this what I have written is only the difference in dono ka difference. So this is the distance traveled in 1 second. Now if we take the distance traveled in 1 second and we divide by time, what do we get? Speed. So what is the distance traveled in this between this? 1. Distance traveled between this and this is 7 in 1 second. So that distance traveled is different for each of them, but it is not constant. So even the change in velocity is not constant. Therefore, we can say that the acceleration is increasing, because they are increasing but not with the uh, same difference. So that there is acceleration. If the velocity was changing with the same difference between time, so velocity change in velocity upon time is acceleration. If the acceleration was constant, if acceleration was constant, then the velocity would have changed with the same rate every second. But since the velocity is not changing at the same rate per second, that means the acceleration is not constant. It is either increasing or decreasing, and in this case we can see it is increasing. Okay. And what do you infer about the forces acting on the object? Well, force is equal to ma object mass remains the same. So if acceleration is increasing, force is also increasing. Okay, direct proportion. What is the shortcut to this? एक simple shortcut बताती हूँ. I don't know if you will be able to think that way, but ऐसे सोचोगे तो you will be able to get the answer without having to calculate all of these things. If you observe these values, these are cubes. 0 cube, 1 cube, 2 cube, 3 cube, 4 cube, right? So these are cubes of consequent numbers, right? Consecutive numbers. So here it is increasing by cube, but what is acceleration? Meter per second square. This is cube, this is square, which means it is not constant. If it was increasing by square, then I would have said that it is constant. I will tell you how. Hmm? Let us take squares of these, right? Sorry, I should not have. So anyway, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49. Okay, now look at the difference of these 1, 3, 5, 7. इसका difference देखो, ये distance change हो रहा है. It is at the same interval. I mean, they're changing exactly by 2 every time, which means that there is no change in velocity. It is moving with constant velocity, right? Do you see? Did I say velocity? No, it is moving with constant acceleration. I'm sorry, because this is the change in distance. So in 1 second, it is moving more distance as compared to one. So इधर 3 ही मीटर किया, इधर 5 मीटर किया, इधर 7 मीटर किया, in 1 second. But that difference is constant. So velocity is changing with a constant rate, at a constant rate. Then in that case, the acceleration would have been constant. But here, as you can see, it is cube. If you can think of it mathematically, this becomes much easier. You could easily have said that it is increasing because a cube से change हो रहा है and it is not increasing at a constant rate. Even the acceleration is not constant. It is not a uniform increase. Okay. If it is too confusing for you, don't think about this. Okay. Use the formula that was given initially. Okay. So I think this is the last one. Two persons managed to push a motor car of mass 1200 kg at a uniform velocity along the road. We have not been given the velocity. The same motor car can be pushed by three persons to produce an acceleration of 0.2 meter per second square. With what force does each person push the motor car? Assume that all persons push the motor car with the same muscular effort. Now, if one person is pushing the motor car, then the force would be F. Here, two people are pushing the motor car, but we have not been given anything else. Motor car ki mass remains the same, of course. So whether one person is moving or two people are moving, then the mass of the car remains the same. So here we can assume that since three people are pushing, there is 3 times the force and they are pushing mass 1200 with an acceleration of 0.2 meter per second. है ना? So 3F is equal to 240, right? F is equal to 240 by 3 is 80 Newton. So every person pushes with a force of 80 Newton. Okay, you can also find that two people push the motor car of this with this force. So how much velocity will it get? And what would the acceleration would be? So you can find all of these things. Next question. A hammer of mass 500 kg, that is 0.5 kg, moving at 50 meter per second strikes a nail, which means strikes a nail, it comes to rest. The nail stops the hammer in a very short time of 0.01 second. What is the force of the nail on the hammer? Now you have V is 0. So you have mass UTV. What do we know about force? Force is the rate of change of momentum. Force का formula F is equal to MAB है and M into V minus U by TB है. F is equal to mass into velocity is 0 minus 50 upon time is 0.01. So this is minus 50 into 0.01. What we can do is multiply it by 100 and divide it by 10 to remove the decimals. Sometimes it is easier to take a longer route because if you make mistakes with decimals, your answer can go wrong. Okay, right? 5 into 50 upon 1 into 10, and this is 100. This is 2500 Newton. Right, this is the force, and please keep in mind that there's a negative sign. Why is there a negative sign? Because the force is opposing the direction of motion. Okay, this is the answer, minus 2500 Newton. Next question. A motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 km per hour. Now you can change it to meter per second. 90 into 5 by 18 is equal to 25 meter per second. Its velocity is slowed down to 18 km per hour in 4 seconds. So V is equal to 18 into 5 by 18 is equal to 5 meter per second. Time is equal to 4 seconds by an unbalanced external force. Calculate the acceleration. How do we calculate the acceleration? Simple. V minus U by T is equal to acceleration 5 minus 25 upon 4 is equal to minus 20 upon 4a is equal to minus 5 meter per second square. Minus 5 meter per second square. This is the acceleration, right? And why is it minus? Because it is reducing the speed. So it is opposing the direction of motion. Find the change in momentum. Now change in momentum is also simple. P is equal to momentum mv, and change in momentum will be mv minus mu. Mass remains the same, so mv minus u. P is equal to m is 1200 into change in velocity is 20 minus 20, right? Because final velocity is less, so the momentum, change in momentum will be minus 24,000 Newton kilogram meter per second. What have I written? Okay, and then what is the force, magnitude of force required? Force is equal to, there's no space here. Okay, force is equal to mass into, force is equal to rate of change of momentum. So what is the change in momentum? 24,000, and rate is divided by time, therefore rate of change of momentum is minus 6,000 Newton. So this is the force that has been applied. Okay, understood? I assume you have understood because I can't hear you. All right, so that was the end of the numericals. This is what we have learned in this chapter, in the entire chapter. I'm just going to revise it. An object moves when acted upon by an unbalanced force. An object does not move, change its state of rest or motion unless an unbalanced force acts on it, right? Force of friction always moves in the opposite direction of object of motion and opposes the motion of the object. Now we also saw examples in which we had to subtract the frictional force from the net to get the net force, right? First law of motion, an object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an external force. Hmm? The natural tendency of objects to resist a change in their state of rest or of motion is called inertia. Inertia, mass of an object is the measure of its inertia. So higher the mass, higher the inertia. SI unit of mass is kilogram. The momentum of an object is the product of its mass and velocity and has the same direction as its velocity, right? Momentum P is equal to mv. SI unit of momentum is kilogram meter per second. Second law of motion states the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. We have also used it in formulae, right? Rate of change of momentum. F is equal to ma. The SI unit of force is kilogram meter per second square, also known as Newton. 1 Newton produces an acceleration of 1 meter per second on an object of mass 1 kg. And we used unit mass and unit acceleration in this because we had to remove the constant of proportionality, right? If you remember. Third law of motion states that to every action there is an equal and opposite reaction which acts on different bodies. The action and the reaction both act on different bodies. They don't act on the same body, therefore they do not get cancelled out. In an isolated system where there is no external force, the total momentum remains conserved. What is a system? When there are two balls that are colliding with each other. If they stick together or if they move out together, they become one system. They are part of a system. And the total momentum of that system is always conserved if there is no external force acting on them. Okay? I hope you have understood this chapter. It is not exactly confusing if you understand the concepts properly, if you understand the fundamentals properly, if you remember the formulae, it is easy to solve the numericals also. Okay, if you have not seen, if you have not understood any of these things, please see these things again. Until here is part 1, right? This is part 2 and this is part 3, right? So these are the parts, and this is, if you have not understood any of these, I think until this is part 1, right? Idhar tak hai momentum ka. So if you have not understood, please watch these videos again. If you still don't understand, please email us or write us a comment below. I hope you have also understood the questions that I've solved with you, the numericals, because these are very important and you can be asked such numericals, or just sometimes people just copy paste these numericals because they assume that you have not solved them. So you can solve these and you can solve other numericals so that you understand the concepts and you understand how to apply the formulae. Okay. If you have any issues, just write to us on the email ID given below. If you like this video, please like it. Please give it a thumbs up. Please comment on our video if you like it, or if you don't like it. Please subscribe to this channel and share it with your friends if you think they would also like it. And please press the bell icon so that you get updated every time we put up new videos. Okay. So thank you for watching. Bye.